Hello, and welcome to the Week 13 Toolkit. Number one. Now, this expression is called a rational expression. Okay, so it is your favorite thing, fractions, and this fractions involve expressions. Okay, so the fractions are going to have variables. So, number one. Now, the most important thing in simplifying this, if I have 5 over 10 times 2, or 5 over 10 plus 2, okay? The first one, the two numbers on the bottom are separated by a multiply sign. The second one, the two numbers on the bottom are separated by a plus. Okay, so the question is, when can you cancel? Okay, you can only cancel things that are separated by a time sign. So divide by 5 is 1, divide by 5 is 2, is equal to 2 times 2 is 4. Now, the second one, you cannot cancel the 10 because that plus sign actually hooks those two together as a BFF couple. So that is just 5 over 12. No, that cannot be reduced. Okay, so you need to remember, when can you cancel things? When they are separated by multiplication signs. Okay, so can I cancel those p squareds? No, I cannot. So what we're going to need to do is we're going to need to factor to get multiplication signs. Phew. So you're going to need to know how to factor. Okay, so the bottom, the greatest common factor is 4p. So I have 3p plus 2. And then on the top, I could say this is 4 times 7 times p times p. Notice multiplication signs. Okay, so there's really a times sign right here. Now, this plus sign hooks them together. We call the 3p plus 2 a BFF couple. Now, think of junior high girls. Does one junior high girl go to the bathroom all by herself? No, she does not. She brings her BFF with her. They are inseparable. Okay, so BFF couples are inseparable. Okay, so what can we cancel? Only things separated by time signs. Cancel the 4, cancel the p. So what do I have left? 7p over 3p plus 2. Can I cancel those p's? No, because that's a BFF couple. The 3p and the 2 are inseparable. Okay, so one thing about rational expressions. So sometimes we have a fraction with a 0 on top. So with your calculator, what's 0 divided by 1 equals 0? Everything's okay there. With your calculator, what if we have a fraction with the 0 under the fraction in the denominator? Okay, if the 0 is under, and if you try to do 1 divided by 0, you're going to get error. We call this undefined. Like under, undefined. You cannot have a 0 on the bottom of a fraction. So state the excluded values. Excluded values, ignore the top. Take the bottom, set it equal to 0. Add 1 to both sides. Actually, set it not equal to 0. So k is not equal to 1. Okay, number 3, x squared minus 9x plus 14 is not equal to 0. So it's just like we're solving when it was equal to 0. So we're going to factor, split, and solve. So we need two numbers that multiply to get 14 and add to get negative 9. So that's negative 7 and negative 2. So we have x minus 7 and x minus 2 cannot be 0. These are one-step equations. X cannot be positive 7 or positive 2. Okay, so here is something that actually you learned in Algebra 1, but it's going to be an important piece of the puzzle and it's going to show up. How do you simplify square roots? Now, the first thing I notice is inside number, inside number. Do you know what I mean by inside? If there was a 3 out here, that would be outside. The inside numbers can be reduced. Okay, divide by 2 is 1, divide by 2 is 5. Now, what is the square root of 1? The square root of 1 is 1. So this is 1 over square root 5. Nikki, hush. Okay, so now we need to rationalize the denominator. No radicals in the basement. So we're going to multiply by the denominator over the denominator. So rad 5 over rad 5, which is rad 5 So rad 5 times rad 5 is rad 5 squared. The square root cancels the squared, and that leaves 5. Okay, let's look at that. Rad 5 squared is the same as radical of 5 squared, which is radical 25, which is 5. Very important piece. Okay, number 5. Now, this is not new, but it's going in a different direction than you're used to. Now, I am giving you the roots, and you give me the polynomials. So if the roots are negative 5, 3, and 5, we change the sign. The factor pairs are x plus 5, x minus 3, and x minus 5. Okay, so we want a polynomial. We are going to need to multiply those together. Now, I see that those two would be easy to multiply together. X plus 5, x minus 5. That's the difference of two squares. So this is x squared minus 25. Okay, so we're just going to multiply them together. If you want to do these two first and then take the answer and multiply by the x minus 5, that's fine too. Okay, so I need to multiply this out. I have 2 by 2, x squared minus 25, and x minus 3. So I have x cubed minus 3x squared minus 25x and plus 75. So the polynomial f of x is equal to x cubed minus 3x squared minus 25x plus 75. There is our polynomial. Okay, find all zeros. We're going to put a 0 here. So this one looks like it's factorable. And I can't do quadratic formula on a cubic. It is for quadratics. So step 1, GCF, factor out the x. Okay, let's see if we can factor this quadratic. Are there two numbers that multiply to get 4 and add to get 4? Yes. So we have x plus 2, x plus 2, or x plus 2 squared. So what are the zeros? We have this one is 0, and this one is -2 multiplicity 2, right? From the exponent. Write a function that produces this graph. This was actually on your week 5 exam. Okay, so we have our zeros. So the zeros are -2, and we see a bounce, and +4, and that one does not have a bounce. So if it has a bounce, it is multiplicity 2. So we have x plus 2 squared. Yeah, it's like a little parabola times x minus 4 with some coefficient for a. Okay, you with me? Not too bad. We know that. We know that if it bounces, it's multiplicity 2. If it cuts through, it's multiplicity 1. Okay, now look at this point right here. That point is, so we have an x1, y1, which is 2, -8. What is my next step? Plug it in, plug in the -8 for the y, plug in the 2 for the 2. So I have -8 is equal to 2 plus 2 is 4 squared is 16. 2 minus 2 is -2. So -8 is equal to -32a. Divide by -32. A is equal to +1/4 or 0.25. So our equation is 0.25 x plus 2 multiplicity 2 and x minus 4. Okay, so we have a degree 3 polynomial. So we're going to put a 0 here and solve. Now I am given the information that +1 is actually one of the zeros. So let's do the possible rational zeros. We have the p's over q's. The p's are ±1. The q's are ±1, ±3. And now we make fractions. 1 over 1 is 1. 1 over 3 is 1/3. Okay, so there's only 4 possibilities. 1, -1, 1/3, -1/3. And I need 3 roots, but some of them might be complex. And so we don't know. We're going to find out. But I know that one of the zeros is 1. Okay, so my polynomial is x minus 1 and then something. Okay, so let's take the 1 and let's divide. So I'm going to do synthetic division, take the coefficients. Step 1, bring it down. Once it's below the line, multiply, add down, multiply, add down, multiply, add down. Good. I got a remainder equal to 0. So yes, my arithmetic worked. So +1 is definitely a root. And this tells me what's left. So now I started with x cubed. I'm peeling it down a layer. So I have 3x squared, 2x, and -1. 3x squared plus 2x minus 1. Now, it'd be really nice if we could factor this. Let's see, rainbow, 2 numbers that multiply to get -3 and add to get 2. Yes, 3 and -1. Put those into our box. 3x squared and -1. The 2x splits into 3x and -1x. So GCF of the top row. Three x times x, 3x squared. 3x times 1 is 3x. X times -1, and -1 times 1 is -1. That works. So now we have x minus 1, that was given. And then this one is 3x minus 1 and x plus 1. So what are the zeros? We have +1, -1. Let's set this one equal to 0. 3x is equal to 1. Divide 1/3.